So enough said, let us go to lesson 3-1. And this lesson introduces you to regression for linear data. Okay, this is about linear functions or linear data, or the data which resembles that of a line. So let us say we have a data here for x days and y setups. For example, you are or you had an injury, okay, prior to the setups. And let's say that's about 2 weeks ago, you had an injury, and then after, after you were hospitalized, and then you get better, and then you were sent home, and then you are coping up with, or you're coping well with your injury, then after that you are feeling well, and you decided to take a sit up. Okay, let's say after day two, you took a sit up and then you did 8 sit ups. Wow, wow, congratulations. You did 8 sit ups. Now, after the fourth day, you did 10 sit ups. Okay? And then after 6 days, amazingly, you had 19 sit ups. So notice how your sit ups are improving numerically wise, okay, or number wise. So on the eighth day, you've got 18 sit-ups. So it's closer than your sixth day. And then on the 10th day, you have 25 sit-ups. So when we graph the data, if we are going to graph the data, okay, it appears to be scattered. It doesn't fit a linear function at all. So let me start with plotting 2 and 8. So 2 and 8 is somewhere here. We have this guide here, so 2 and 8 is somewhere here. And then 4, 10 is, okay, that's a bit off. So let's have 410. 410 is here. And 619 is here. And 18 is here, just way below 20. And then for x is equal to 10, our y is equal to 25, so it's here. And okay, we now had enough of that, so we took away the grids. And now we are going to perform a best fitting line. A best fitting line is a line which somehow fits all of the scattered data into a linear line or a straight line. So we have to analyze the data, of course, by interpreting which of these data in regression analysis, which we are going to have later, then that best fit line will be the line that somehow fits these scattered points perfectly into a straight line. So let me draw you a line which resembles that of a best fit line, and it's this. So you can see this line fits 2 points perfectly, okay? And so let me fit them perfectly because we had some inconsistency with the grids. So let's fit them here and here. So as you can see now, there are 3 more points left, which do not belong to the straight line. So we could somehow put another point here, just to represent the point below. So it would be taken up, and this point would also have another corresponding point here. And this point will have another corresponding point here. So in essence, let's take for example this point here. Now this point will have a corresponding x value, which is x is equal to 6, and also a corresponding value which is here, and we don't know what that value is. But the original point that we have is this, right? Let me make it straight. So it's this, right? And then you could notice that this point here, as compared to this point, has a certain difference in length, or the y value. Now in regression, we call this a residual, Okay, this is our residual. And each of the other 2 points not taken, let's say this one, has a corresponding residual from the point on the line itself. So we have a residual, and let us say this is our y value. So this is our y value, and let's say this is called y hat in the symbolic to the regression uh, term, because hat is very important as a symbol in regression. So this is read as y hat. So the residual here, the formula for residual could be taken as residual equals y hat, or rather y minus y hat. Am I correct? Okay. So just to give you a brief clue on this residual term and regression analysis for the best fitting line, this is our best fitting line. And they found it using a series of computations. In your book, they found it using a series of computations. So this equation for the scattered data that we have as per the table is concerned is y is equal to 2.1 x. That's y hat is 2.1 x plus 3.4. This is the best fitting line equation. Okay? So for the next lesson, we are going to have some problems set regarding this table here, this data, as well as some regression analysis, and also prepare your grapher, because we're going to analyze if you have a grapher. Now, if not, you can rely on the manual graphing. Okay? So this is it for today. And for the succeeding lessons, as I've said, we're going to uh, compute for the regression analysis, at the same time to compute for the best fitting linear function, and go directly to lesson 3-2. So I hope you enjoyed listening to this video, and thank you for watching and listening. Have a nice day.